first.
Anybody? Thank you. You guys, we did this all last time, right?
Practice makes perfect. Better. Practice makes better.
You guys all remember that from last time, the power rule? You gave me a hard time with the binomial theorem. Another specific one. With respect to x of e to the x's. The derivative with respect to x of anything else raised to the x's. Well, you guys actually, can I stop? Those are specific derivatives. Let's talk about general differentiation rules. To differentiate with respect to x some constant times some function with respect to x is just going to give you that constant times f prime of x. That's something else we established before the exam. We also established that the derivative with respect to x of the sum or difference of two functions is nothing more than the sum or the difference in their individual derivatives. And we put that to practice as well. It's just that when it comes to derivative with respect to x of either a product or a ratio, you do not get the product of their derivatives or the product, or excuse me, or the ratio of the derivatives. In other words, you guys, life isn't that pleasant when it comes to multiplication and division through the differentiation process. Matter of fact, can I justify this real quick?
X squared.
No tricks. Is this true? Sorry.
No.
My apologies, Christian.
Well, yes. Yes.
You know, technically speaking, I think I'm okay because I didn't differentiate. I cheated. And so, before I differentiate, I just multiply this piece together. I get this. That's not the same as this. Which is this. Do you guys see how with this example I've illustrated that to differentiate a product is not the same as what you get when you multiply the individual derivatives? So I think what you and I need to do tonight, we need to create a process by which we can differentiate a product and we can differentiate a ratio. That's what I want to do next. This is not physics, it's not biology. I'm not going to come to class and say, hey, here it is. Because it's a mathematics course, I want to justify everything I say. So here's my justification. Let me derive these differentiation processes. And you guys, you nail me at any stage of the game. Let me know if I'm saying something that's not clear. Wow, we sure lost a few of us during the break, didn't we? Oy, oy, oy. So to differentiate the product of two functions, you guys check this out. I think by definition, I merely get the limit as h goes to 0 of a difference quotient, which is my new product function, evaluated x plus h, minus my product function, evaluated x, all over h. I'm just using my definition of derivatives, nothing fancy. But you guys learned back in Math D that given two functions f and g, a new function called the product of f and g has a quality that its output is nothing more than f evaluated the input times g evaluated the input. And likewise over here, the new product function evaluated x is going to be nothing more than a result as the product of the outputs for f and g individually when the input is x. And if you guys don't mind if I come in with my green pen and just insert a funky looking form of 0 in the middle of that numerator upstairs. So in black, here's my first term. In black, here's my last term. You guys, in black, I haven't changed anything. But if you allow me to come in here and subtract off maybe, how about an f of x, g of x plus h? And then add it back in. You guys, I know this looks goofy, but you have to confess, sitting in your chairs, look at what I wrote on the board, this is perfectly legal. I just added a funky looking form of 0 in green. It's just that if I take a mathematical ax right there, then I think that gives me the limit, as h goes to 0, of this beast. Plus this beast. You guys, this is important. So far, so good. However, since I've got the limit of sum, wouldn't that be the same thing as the sum of two limits? And I think, when it comes to this numerator, I can pull out a factor of g of x plus h, but the limit of product is a product of two limits. And I think over here, I can pull out a common factor of f of x, but jeepers, the limit of that product is going to be a product of two limits. Would you not agree in the end, I'm merely left with a limit? As h plays its game of, actually I lost track, is that a g of x plus h? Times the limit, as h plays its game, of this business. Bless you. Plus the limit of my f of x as x plays this game. Ooh, I misspoke. I meant as h, not x, plays this game. Times the limit as h goes to 0 of, well, what the heck is left over? Is that a g of x plus h? Minus g of x all over h. And I think when I value the very first limit, as h goes to 0, you guys know tricks. Doesn't this whole thing right here just go to g of x? And do you guys recognize this expression? What's another name for that mess?
F prime.
Very nice. Plus, how about just f of x?
Yeah.
I mean, who cares what h does? The limit of f of x, h does anything is going to be f of x. Times
G prime.
Very nice. Bless you. Now I gotta confess, you guys, with these two operations of multiplication and this one operation of addition, if you reorganize these factors of terms, it makes no difference. We have commutativity working for us. So as a general rule, to differentiate the product of two functions, I get the first as is, do not touch, times the derivative of the second, plus the second as is, do not touch, times the derivative of the first. This is so important, I'm going to give it a name. I'm going to refer to this as my product rule for differentiation. This is how you and I are going to differentiate the product of two functions. And so if I asked you guys to differentiate with respect to x, the product of root x and, I don't know, how about e to the x? To differentiate such a product, I think I'll dive in. And simply grab the first as is, do not touch, multiply by the derivative with respect to x of the second, plus the second as is not touching, times the derivative with respect to x of the first. You guys are going really, really quiet. Please interrupt me. And you just tell me to slow down if I'm talking too fast.
Now, I'm still a little bit confused on the notation, the d over d of x.
Do you see how I'm intentionally changing notation all over the place? Sometimes using y prime, sometimes f prime of x, sometimes as differential operator. I love this notation because it tells the reader I'm going to differentiate what's inside.
So when would you use d of y?
That's different. I think if y is equal to e to the x, the derivative of y with respect to x is equal to e to the x. It's just if I'm diving in and differentially operating on something, then I use this notation to tell the reader I'm about to differentiate.
Okay. So it would be d over d to the x when you're differentiating something on the inside of the.
I like the way you said that. I think it's perfect. In fact, why don't we do it just now? I think I'm left with the root x times plus e to the x times 1 over 2 root x. Or, shall we say, we can pull out a and a 2 over root x. That looks so much better. And that's easy with a
Root x 12.
math D.
This is the weirdest math D.
2 x plus, I feel so alone. I can't believe something like that.
How can you pull out a 2 root x on the bottom if there's no 2 root x in the first? Like,
Did you give them
Show us the
common
steps.
denominator?
What would you pull out of here?
X?
Well, you mean x squared, right?
No.
What do you mean, no, why not?
there's not an x squared.
There's only one x squared.
Oh, I see. So what you're really doing is you're pulling out x to the smallest power you see,
Yeah.
which is 1. But I read this as an x to the negative 1/2. And the smallest power to which x is being raised to from negative 1/2 to 1 is half is just negative 1/2. All right,
I get
don't
it.
listen
I get
to
it.
me.
I get it.
I got a better idea. Why don't we just find a common denominator? You will see I'll get the same answer. You will see, you will see. Oh, there's the only fraction I see. There's this denominator. So, let's force the issue. Now I can rewrite all this garbage as a single fraction all over 2 root x. It's just what's left over is, let's see, x times, I misspoke. Root x times root x is?
X.
Oh, I lost a factor of 2, and I lost a factor of e to the x. Yes, Giselle.
Where do you get 1 over 2 root x?
It's the derivative of the square root.
I'm so sorry, Giselle. You're saying where did I get this?
Yeah.
My apologies. I got it from here. So check this out. To differentiate with respect to x, root x, don't you agree on differentiating with respect to x? No calculus, algebra. Am I not differentiating this? Ah, but now I get to use a power rule. I wrap my fingers around the exponent 1/2. I bring it down to the level of everything else and reduce my exponent by 1. But that's merely just a 1/2 times 1 over x to the 1/2. Or shall I say 1 over 2 root x? That's where I got that from. And everybody, since you mocked me for writing what I had on the board before, I got an idea. I'll pull out the 1 over 2 root x. Oh, I'll pull out the e to the x. And here's what's left over.
Okay.
Being a white approach.
It's just that easy.
It's just that easy, yes.
Would we be more wrong if we use the second one, the supposed other one?
Oh, you wouldn't even think of you doing that.
What?
I'm serious because in the near future we're going to be looking at applications. We're going to have to set the thing to the zero. We have to be able to recognize exactly what the zeros are immediately. I taught one spring a Math 33, and I had a student get so irate with me about saying everything's Math D. He took my Math D the following summer. He didn't earn an A. Yeah, it's amazing. It was illegal, so I just didn't register him. He just sat and took all the tests. You wanna know what math D was all about?
Well, you can't take a lower math course.
Oh, you guys may not be aware of this, but if you pass this course, you're done. You can't backtrack. It's not legal for you to take any course below calculus. It's state code.
What if we
Well, you can always go back and do that.
What's
Can
that?
we take, if we get a C, can't we take it again? I thought.
Absolutely not. No, you'd have to petition for that. And you wouldn't be able to take any class lower than this.
Really?
Yes.
What?
Well, when I say lower, I take that back. I mean, any lower class that's a prerequisite for this. You can go back and take stats because that has nothing to do with calculus.
Oh, okay.
But nothing that leads up to the calculus. What was that? I didn't hear that. It might be a good thing. You guys, watch how I'm writing this question completely differently. If f of x is equal to x squared minus x plus 3 times 3x squared plus 4x minus 5, then let's you and I determine the derivative for f with respect to x. I think it's the same question I asked my last question. I'm just posing it differently. Help me. What would you do? So you're going to differentiate the first. Times the second. Plus the first.
Plus 4.
Times the derivative of the second, which is 6x plus 4. Do you guys agree?
Well, unless you care about the order, then.
Yeah, I don't care about the order. Notice how I switched this time from what I did the last time because I was following what somebody was saying. It's completely irrelevant because commutativity holds for addition as well as for multiplication.
Are those all 6x, those 3's in the top, right top, the first initial, is that plus 3 and then 3x squared and then minus 3?
Yep. 3x squared plus 4x minus 5.
Oh, minus 5, okay.
That's a pretty five.
So if you just FOILed out the top and then
I know.
took the derivative
Thank
of
you.
that, wouldn't
Did you hear
that?
what he just said? He
Yeah.
said if I multiplied out all this garbage first, it'd be a lot easier to differentiate.
Yeah.
I agree. Now that I've gone this far though, because I'm just getting practice with product, I
Okay.
can clean up. I think 2x times each of these three is this. I think negative 1 times these three is just this. I think 6x times these three is going to give me 6x cubed minus 6x squared plus 18x. And I think a 4 times these three is going to give me a 4x squared minus 4x plus 12. Now I got some like terms to combine, don't I?
Where'd you get the 6x plus 4?
I got that from differentiating the second. And when I differentiate the second using the power rule, I bring the 2 down, getting a 6, and reduce the exponent by 1. That's where this term came from. And differentiating the 4x is just going to give me the 4. Do you guys agree? Do you guys mind if I don't take time off that clock and finish? Now it's just a matter of collecting my terms, right? After all, I want you guys to see, oh, how beautiful it would be to differentiate the ratio of two functions. So let's do that. I think to differentiate with respect to x the ratio of two functions, since you guys have not seen this before, I have no choice. I got to use my definition. I will. I think that gives me a limit as h plays this game of this ratio function, ev added x plus h, minus this ratio function, ev added x, all over h. But by definition, in terms of math D, of the ratio of two functions, I think it's just simply a function whose output is a ratio of these two outputs.
Are you going to be adding or subtracting some function form?
Absolutely. You guys, the whole idea of adding adding a funky looking form to zero, from here on out, is going to occur so often in mathematics. Every semester you study math. You guys, personally, I don't know if I really like what I'm writing. Can I just clean it up first? I see fractions embedded in fractions. Do you mind if I clean that up by multiplying top and bottom? By this blue piece? It's perfectly legal because I'm merely multiplying by this funky looking form of 1. I just think it's terribly useful because you check out what the heck happens upstairs. When I distribute these two b's to the first black fraction, my g of x plus h is cancelled. And I'm merely left with a product of my f of x plus h with my g of x. When I multiply these two b's to the second black fraction, now my g of x is cancelled, and I'm merely left with an f of x times g of x plus h. Oh no, I forgot my denominator. I guess that's the product of h with g of x with g of x plus h. Oh no, we also forgot our limit. I'll put it in. And with my black pen, you guys, I'm serious, I'm not going to change anything. This is the limit as h goes to 0 of my f of x plus h times g of x minus my f of x, g of x plus h. All over stuff. And here, with my green pen, is where I'm going to insert another funky looking form of 0. I'm going to subtract off the product of f of x and g of x and add it back in. Perfectly legal. Yet again, I'm adding a funky looking form of 0 to that numerator. And like I did in actually deriving that product rule, if you guys don't mind, I'll take a mathematical axe right here and treat the limit of a sum as a sum with two limits. And then maybe even pull out some like factors, and you just watch what I'm writing and tell me if I write something incorrect. Would this be this? The limit as h goes to 0 of what I pull out was the common. Times the limit as h goes to 0 of my f of x minus f of x. Excuse me, f of x plus h minus my f of x all over h. Minus, this time around I'm going to pull out an f of x. Take this limit. Times the limit of what the heck is left over as h goes to 0, but that's just simply going to be, is that a g of x plus h? Minus g of x all over h. You guys, this is important. I want you to analyze what I have on the board, because I think from the previous line there's something missing. What is it?
Plus.
Well, I pulled out, if you don't mind, I did something kind of funky. I pulled out a negative sign from both these two, which just kind of swamped them. So that's legal. There's something else missing. What is it?
Plus. Your denominator?
Thank you. My denominator is missing. And so I think I need to divide by the limit as h goes to 0, the product of these two pieces. And I'll let that marinate for a moment. You let me know if there's something unclear with what I'm writing. This time no tricks though. I'm okay.
Would you just split them up now? Another mathematical axe down the negative one?
I don't think I have to. All I think I have to do is just make some proclamations. Help me with this. What's the limit of g of x as h goes to 0?
G of x.
Oh shoot, you guys are on a roll. What's the name for this second factor?
Prime.
Keep going.
Minus f of x.
All over.
G of x. Some weird.
G of x. If you
How
X
about
plus
square
A.
root?
Shoot, that's so important. I'll give it a name. I'm gonna start calling that my quotient rule for differentiation. If ever I want to differentiate the ratio of two functions, that's what I will use. Well, unless you can use some math skills and clean it up first. But we did that last week in class.
Is that g of x squared on the bottom?
It is. Do you see where it comes from? You know, technically speaking, when I value this limit as h equals 0, g of x stays as g of x, but it's being multiplied by, well, as h equals 0, another g of x. This is where the g of x squared comes from.
Makes sense.
So, if y is equal to this nasty business, can you and I come up with this? So let's give it a shot. To differentiate such a ratio, I might be writing too much. This is my first application of the chain rule. It's my first application of the quotient rule, so I might be overriding what's on the board. You might be skipping some of this. I think according to the chain rule over there, the structure, what did I just say? I'm stuck on the chain rule, whatever the heck that is. With the quotient rule, I think to differentiate my f of x over g of x, I get my g of x downstairs as is, do not touch. Times the derivative with respect to x of whatever's in the numerator's position. Minus the numerator as is, do not touch. Times the derivative with respect to x of whatever's downstairs. All over what the heck is downstairs squared. Now let's you and I dive in and differentiate where appropriate. I think this is my root x plus 1 times minus my root x minus 1 times my all over stuff. Ah, shoot, we trained you guys back in Math B not to be happy with this, because I have fractions embedded in fractions. So you guys instruct me with my blue pen.
2 root x.
What about it?
Multiply top and bottom.
I agree with that. Let's multiply top and bottom by 2 root x. Cancellation all over the place upstairs in the numerator's position, but jeepers, doesn't that just simply leave me with root x plus 1 minus root x minus 1? All over stuff. Well, I did, Christian, I did slip it up down here. So I just wrote it on there as a process.
Oh, yeah, no, I meant, simplifying.
I agree. Next, I think number 1, this set of parentheses is superfluous. Number 2, if I remove these parentheses, I change signs all over the place. Doesn't that in the end merely leave me with a 2 over 2 times stuff? Or shall we just say 1 over stuff? Very cool. What does this represent?
How'd you get the 2 in the numerator?
Watch me. First set of parentheses is superfluous.
Oh, my goodness.
Second set of parentheses I'll remove and distribute to negative 1n. But don't these cancel?
Ah,
And am I not merely left with this?
yes.
And then I can cancel. See, you guys just don't trust me.
We just don't know.
So if I came into class and just talked gibberish, you just accept that?
As long as, are we tested on it?
It's a math class, it's supposed to justify it. So So where are we on the happy scale? Yes.
So is it okay to have,
I'm sorry.
is it okay that now we have, square root on the bottom? I don't know.
Oh, by far, you've got to get used to it. What they trained you back in algebra is completely wrong. When they told you rationalize denominator, don't listen to them anymore. It's just going to make your life so miserable. Your life is so much easier this way.
So what does that represent?
You know, depends on your interpretation. Here's one thing it represents. I think this represents a whole new function called the derivative function, where at any value of x, this will give you the slope of the tangent line to the graph of this equation at any value of x. Or, I can say it this way, with this whole new derivative function down here, I think at any value of x, this gives you the instantaneous rate of change of y with respect to x to the original curve. So far I've got both those interpretations. Well, actually, there's a third one, because I discussed this already, as well as your author. If this were a position function, and at any value of time x, then I think this will give you the velocity at that corresponding value of time, whichever the value of x is going to be. And to differentiate velocity will give you the acceleration function. So a second derivative function application would be acceleration. If the original function is a position function. Are you happy?
Static.
I thought you could.
Sounds like it.
What do you think? Anybody?
X squared plus 1.
So what's downstairs times e to this what's upstairs derivative minus the 2x which is derivative downstairs times what you see upstairs as is. I know you switched those, but who cares? Multiplication commutes. All over x squared plus 1 twice. Oh, it's cleanup time. Does that give me an x squared minus 2x plus 1 times the e to the x all over x squared plus 1 twice? Is that okay? Or, if you so choose, you can think of this as x minus 1 twice times e to the x all over x squared plus 1 twice.
That's it?
Not much else I can do to clean it up.
So for that, you just plugged in the equation 7 into the last rule over there?
Absolutely. Oh, that was so much fun. Let's do it again. I think, to differentiate with respect to x, this ratio. You guys, maybe I've talked too much tonight. Why don't you just take a break, relax, and spectate? It's downstairs. Times derivative upstairs. Minus upstairs. Times derivative downstairs. All over downstairs. Twice. Or shall I say 3x cubed minus 3x squared minus x cubed plus 1. All over stuff. Or shall I say 2x cubed minus 3x squared plus 1 over x minus 1 twice?
Wait, that's not up.
Oh, no. I need some scratch paper. I got an idea. Let's use some synthetic division with the rational root pair. Let's see if I can break that numerator up. Ah, shoot. Isn't that nice? So, making this example of that, I think that numerator factors quite nicely into an x minus 1 times a 2x squared minus x minus 1 all over x minus 1 twice. Or shall I say, x minus 1 times you guys aren't gonna help me, are you? You always make me do this.
Spectate.
That's right, I did, didn't I? All right, I'll keep my word. Or maybe, whoa,
Yep.
isn't that slick? What? Did I just waste 2 minutes of your life? Did I just waste 2 minutes of your life?
The party trick.
Yeah, I did. Never dive into any calculus. I'm not wrong. I'm completely correct. But always try to rely on your mathy skills first. So, how about question number 8?
That's 8.1.
I have it.
No calculus.
Yeah.
Isn't that the-
X squared, plus 2x, plus x, plus 1.
Oh, shoot, check that out. I'm just differentiating with respect to x. My x squared plus x plus 1. No quotient rule. That's just x plus 1. But you guys see my point. You do want to use your math skills first. Don't dive into any extra work.
Yeah, that's what my last guy was class, they told me that, it's like, it's easy way to do it.
Yeah, absolutely. Always, always, always. How am I doing on time? Oh, beautiful. 8:18.
Not so good. Can do a lot in 5 minutes.
Can I set you guys up for tomorrow?
Wednesday?
Wednesday.
Can't count very well.
I'm a terrible counter.
You kind of like become worse at basic math as you go up like.
Yeah, the more you learn mathematics, the worse you are with arithmetic. It's just awful. It's awful.
They have apps for that.
Yeah, what?
Apps for that.
Apps. Unit circle.
What's the unit circle?
It's a circle whose radius. I took you seriously. Touche. What do you guys think you could say about the lengthless line segment? Oh, sorry, hold on. Look at my picture carefully. I meant this to be a right angle. My apologies. Both of those. Come on, you guys just panic. What can you say about AB's length?
Isn't the sign of the?
Thank you very much. I think it's a sign of this angle right here. However, I think the relationship between the length of the line segment AB and the measure of the arc from A to C, which one's bigger? Yeah, I think so, just because of the contour of the circle. And what's the measure of the arc from A to C? I asked, what's the measure of the arc from A to C? I can ask a third time. Very nice, it's just T. Did you guys see that?
No.
Well, for any circle whose radius is r, and here's the central angle theta, isn't the length of this arc called s? Isn't s just nothing more than r times theta?
Yeah.
So in my picture, my s is equal to my radius r, which is 1, times my angle t. So the length of the arc is just t, isn't it? Oh, you know what? If you look what I have on the board, you guys, this is so important. Can I rewrite it? So what I'm really saying is that the sine of t is strictly less, or actually less than or equal to t. Which means if I divide both sides by t, this is less than or equal to 1. That's so important. Can I put it in a box? So let's do something else. You take, let me take a peek at the measure of this arc right here, which is t. Would you guys agree that this is less than or equal to the line segment connecting A to C. Anyway,
Less than, greater than?
which one is it?
Wouldn't it be less?
See, I think it should be the other way around. I think these should be swapped.
Yeah.
But I could do this. If I talk about the measure of the arc from A to C, which is just nothing more than t, I think since I meet at right angles here, that the measure of that arc t is going to be nothing more than AE plus EC.